as with chapter 10, there's quite a few formulas that you need to use. I don't expect everyone to have them all memorized, so they are in Canvas, okay? They're in 2 places. I'm going to keep them in this module, this week's module, which I'll update after today to update for next week's stuff. It's also under important documents along with your identities, your chapter 10 formulas. You can use these on exams, okay? And quizzes. So it's going to have quadratic formula, kind of use it a bit in chapter 9. It's going to have the law of sines, that's today. Area of a triangle, that's today. Law of cosines, that's going to be next week. And this other stuff, which is some good stuff. All right, it's not the other stuff is not as bad as it looks, by the way. It's long, but it's not too bad. You just plug things in and simplify. All right, the most difficult is behind us. Okay, so you can find that there and print it out for yourself, or just use it through Canvas. So that's basically what's going on. So let's get into 10.1, law of sines. All right, so we're going to start with like a little example 0. This is a tricky example right here. All right, find x, okay, where I give you some triangle like this. This is what you're supposed to solve. We know that this is a 15-degree angle. We know that this is a 35-degree angle. And let's say that we also know, that this is like, I don't know, 10 miles, something like this. Okay, so this is not a right triangle. It kind of looks like a right triangle, but it's not. It's not. Right, we know this angle too. All the angles together add up to 180 degrees. So these two together are 50. This has to be 130 degrees. So definitely not a right triangle. So in the past, we solved this with a system of equations. We said we can turn it into 2 right triangles, like so. Right, and then the sine of 15 degrees is equal to the opposite over hypotenuse, h over x. And the sine of 35 degrees is the opposite over hypotenuse, h over 10. And then what we would do is we'd solve both sides for h and substitute it out. So multiply both sides by x, you get h is equal to the x times sine of 15 degrees. Over here, multiply by 10, you get h equals 10 times the sine of 35 degrees. Another nice thing about this section is we're going to be using degrees a lot again, and a lot of people like degrees, so you can have that going for you as well. And then, since h is equal to this and h is equal to that, these two things must be equal to each other. All right, so you get x times the sine of 15 degrees is equal to 10 times the sine of 35 degrees. All right, and we can do this to solve any triangle that has this sort of situation. This right here, this is essentially the law of sines. All right, that's all it is. The law of sines is just what happens when you don't have a right triangle and you make a right triangle and solve the system of equations. So law of sines is essentially a shortcut that we've already done. Okay, so let's introduce it more formally now. We're not even going to solve this problem, but you could solve, right? You could finish this. But the whole point here is just to introduce where does the law of sines come from, and it comes from this situation. All right, so the law of sines. For a triangle that, I don't know, say the triangle just looks like something, it's just something that's not a right triangle, okay? Then there's a couple naming conventions for triangles. Previously, we've used uppercase and lowercase letters. In this section, the book uses Greek letters for the angles. So I'll use that, but you can call these capital A. If you want to use capital A for this angle instead of alpha, go for it. If you want to use capital B instead of beta, if you want to use capital C instead of gamma, go for it. And then the convention is that A is the side that's opposite the angle alpha, B is the side that's opposite angle beta, and C is the side that's opposite angle gamma. Okay, so if you have a triangle like this, can say the sine of alpha over A, that ratio is the same as the sine of beta over B, which is also the same as the sine of gamma over C. Right? And you could flip all of these if you want, right? A over the sine of alpha equals B over the sine of beta equals C over the sine of gamma. However you want to set this up. And the important thing for the law of sines is that you only need to choose one pair. Just look at any pair of ratios. So how we're going to solve these triangles is we're just going to find one pair or one ratio that we know, and then one ratio that we only know a part of. All right. So let's get into the first example and let's use this. Okay. Example 1. Solve the triangle. And again, remember back to chapter 7 when we solve triangles, that just means find all the angles and all the sides. Okay. So let's say you have some triangle where, let's say alpha is 50 degrees, gamma is 30 degrees, and A is 10. So sometimes they're not going to give you a picture. Sometimes they will give you a picture, okay? But you need to be able to turn this information into a picture. It doesn't have to be a good picture. You could draw the worst looking triangle ever. It doesn't matter. What matters is that you get a visualization of where the sides and the angles are with relation to each other. So I'm just going to draw a triangle. All my triangles look the same. Almost. All right, and then we'll just say this is alpha, beta, gamma. Alpha is 50 degrees. This doesn't look like a 50-degree angle, but it doesn't matter. Because you can't draw an accurate triangle unless you know what everything is. And if you know what everything is, why do you have to draw a triangle in the first place? So your triangles aren't going to be pretty. The important thing is that you can put things in the right spot. Alpha is 50 degrees. Gamma is 30 degrees. And I usually go clockwise, alpha, beta, gamma, but you don't even have to do that. You can literally choose any angle for alpha, beta, or gamma. As long as you're consistent that A is always the side that's opposite alpha. So the 10 has to go here. All right, and if there are any questions, feel free to interrupt and let me know. So, what do we have here? Well, we need to find this angle and these two sides. But notice that this angle is super easy to find. You don't need law of sines at all. This is, by the way, what we call an angle-angle side triangle. You don't need to know this, but it's a little fun fact for you. Because we have one angle, and then an angle next to it, and then a side on the other side of it. So angle, angle, side is the order of the things that we know. You could also switch the abbreviation called side, angle, angle. That's essentially equivalent, but this is usually what we call them. All right. So again, we can find beta. That's going to be 180 minus the other angles, right? Because sum of all angles is always 180 degrees in a triangle, and 360 degrees in a square, 540 degrees in a pentagon, 720 degrees in a hexagon, etc. So you find that out and you're going to get that beta is, 100 degrees? You just fill that in. It almost looks like 1,000. And how you express your answers for these is up to you. If you want to box that, oh, beta's 100, box that, you can. But a lot of times what I do is I just fill in the answers on the triangle, and it makes it a little easier to have everything in one place without having to write extra stuff. So I'll just be answering by filling in the triangle. But if you want to box your individual answers, go for it. Okay? So now we're going to have to actually use the law of sines, because now we have to actually solve the triangle. And we need to find these two sides. So we consult the law of sines. The law of sines says, look at any pair of ratios. And we need to know one of the ratios, and the other ratio will be unknown. So we always start by finding which ratio do we know. Right? Find a ratio that we know. So that's always going to be an angle with its opposite side. Here we know 50 degrees, its opposite side is 10. So we're going to start with sine of alpha, which is 50 degrees, divided by a, which is 10. And now we choose some pair that we don't know, some ratio that we don't know. We could choose gamma and c, or beta and b. They're both choices here. You won't always have a choice, but here we do have a choice. We could do either one of them. Okay, so let's choose, I don't know, arbitrarily gamma. So sine of gamma, which is 30 degrees, divided by c, which we do not know. And you just solve this. Okay, so a couple of different ways to solve it. You can cross multiply if you want. All right, if we cross multiply, what do we get? C times the sine of 50 degrees equals 10 times the sine of 30 degrees, and just divide both sides by the sine of 50. All right, and this is nice because you just plug this into your calculator and get an answer. 30 degrees we could calculate exactly, but 50 we can't. Okay? So we will have to approximate. This whole section, I don't think we'll have any exact answers. So you plug that into your calculator. Make sure you're using degrees. This whole section is really going to have only degrees. So what you're going to get is approximately 6.5270. So what I like to do, I like to round to 4 decimals, and I would suggest this for you. But in your final answer, the book only asks for 1 decimal place. So when we fill in C, again, C is opposite gamma, we can just write 6.5. But I like having more decimal places just in case we have to use it, and then we'll have a little bit more precision. Right? If you're using an approximation, the more decimals, the better it is. But if you just have a final answer, that's when it's more okay to round some more. All right. So now we just do the exact same thing with B. We set up a ratio that we know. Why not just use the same ratio that we know, right? Why not just use sine of 50 degrees over 10 again? And then the ratio that we don't know, which now is going to be beta. Beta is 100 degrees over B. You do the exact same steps, just instead of a 30 degrees, you have 100 degrees. So I'm not going to solve this equation again. We already did this. It's going to be 10 sine of 100 degrees over the sine of 50 degrees. And again, we'll just type that into the calculator. And then get about 12.8558, or about 12.9. So we have solved the triangle. Now, something you may or may not know about triangles is that, and this is related to the law of sines actually, there's always a correlation between the size of an angle and the size of its opposite side. So as soon as you answer, as soon as you finish your answer, do a gut check. Okay? So here, I'm going to write it down right next to the triangle. Note, the side opposite the biggest angle should be biggest. And same for the smallest angle. So let's just make sure that that's true, because this can be a great way to catch if you made a silly mistake. So what's the biggest angle? The biggest angle is 180 degrees. What's the side opposite 100 degrees? 12.9. Good, 12.9 is the biggest side. Biggest angle should correlate to biggest side. What's the smallest angle? 30 degrees. Opposite 30 degrees is 6.5, which is the smallest side, okay? So we know at least we haven't completely and totally screwed up. It's a good way and a quick way, right? You can check that in 5 or 10 seconds. It's a very good, quick way to make sure that you didn't do anything really bad. Or at least, if you did something really bad, you'd probably see it here. Okay? That's essentially what's going on here. And this example 1 is the nice situation. Okay? But when you get into some other things, if you get into the situation where you have 2 sides instead of 2 angles, right? This one we had 2 angles, we could immediately find the third angle, and we just use the law of sines twice. But if you have this side-side angle situation, you can have, the book says 4 outcomes, but really it's 3 outcomes. You can have no answer, you can have 1 answer, or you could have 2 triangles that make it work. And the book kind of shows it off this way, right? Sometimes you're gonna get a problem where one of your sides is not big enough, and you can't finish the triangle, and there's just no triangle that solves. Sometimes you'll get only 1 answer, either a right triangle or non-right triangle, where things are kind of nice. And then sometimes you actually get 2 answers. One of them is an obtuse triangle. See how this is such a big obtuse angle right here? And one of them is an acute triangle. So these dotted dashed lines talk about 2 answers. And we're going to have to solve both triangles. We do not like these. Remember, by the way, how I said that you can change the order of how you read these, right? Angle, angle, side. But you could also call this side, angle, angle. Well, this is an appropriate naming here. We have side, side, angle, or you could switch the order and go angle, side, side. And then the abbreviation is perhaps more fitting because these triangles are the worst. All right. Out of all of 10.1 and 10.2, if you have a side, side, angle triangle, that's when things get a little trickier. So a natural question, right? Jason, how do I know whether there's going to be no answer, 1 answer, or 2 answers? Okay. The no answer one is easy. We'll get to that eventually. The 2 answers one is the tricky one, and we'll start with that. I'll show you what happens. How do we even get 2 answers? What do we do with 2 answers? And then we'll talk about the other 2 situations on Friday. All right. So this is going to be a long one. I'm going to need I want a blank piece of paper for this. All right, let's do example 2. I should probably switch my scene so you can actually see my notes. Also, good time for extra credit question today. Let's see. For the extra credit question for today, send me the section number on Discord, the section number from this class that you hated the most. Okay, I was going to say loved the most, but hated the most is probably easier to remember. Send me a section number from this class that you did not like. All right, or you can just send me any section number. It doesn't really matter, but some section that we've covered in this class for the extra credit point today. All right. And then we're going to get to it. So this example really might just take the, I was wondering where my notes were. I forgot I don't have notes today. It might take the whole rest of the class. So we'll just get into it. Example 2. And please ask questions if I lose you in this example. If there's a step I do in this example that doesn't make sense, ask. Because honestly, most of this section should, if example 1 was good for you, most of this section will be pretty easy for you. Example 2, this is where the section can be tricky, okay? So this is the place where you need to ask if something confuses you. Okay, so solve the triangle where alpha is equal to 35 degrees, B is equal to 8, and A is equal to 6. So again, we're just going to start by drawing a triangle. And again, the triangle is probably going to look nothing like the triangle is actually supposed to look like, but let's just draw it. Just draw a triangle. alpha, beta, gamma. It does not matter where you put alpha, beta, or gamma. But alpha is 35 degrees, so fill that in. And then B is opposite beta, so B has to be down here. It's 8. A is opposite alpha, so it has to be right here, which is 6. And again, don't get excited. Well, you can get excited, but not about this. Don't say, oh, this is a 3, 4, 5 triangle, 6, 8, 10. That's only if it's a right triangle. These are oblique triangles. They are not right triangles, so this is not 10. Okay, that's only for right triangles. So we got to get to solving. We're going to solve this the same way as before. So in example 1, we had 2 angles. And we said, okay, we have 2 angles. We can find the third angle. We only have 1 angle here, so we can't cheat. It's not cheating. We can't use a trick to get another angle right off the bat. We have to start with the law of sines. Okay. This example is going to show something kind of cute. All right. So to use the law of sines, remember, here's the law of sines. We need to, I like right triangles too. They're a lot simpler, but these aren't as bad. So we need to look at any pair. So we need to find a pair that we know its angle and its side opposite, and then set that up, and then we'll use another pair to find something we don't know. So the pair that we know alpha and A, this angle and this opposite side. So that's how we start. We know the sine of alpha, alpha is 35. Sine of 35 degrees over A is 6, equals to the sine of something divided by something. So we need to find an angle and its opposite side, and we need one of these pieces of information. Well, we only have 3 pieces of information. We've already used 2. So the other thing we know is B. B is 8. And so the unknown then becomes the angle opposite that, which is beta. Yeah, good. So we have to solve for beta. This is a trigonometric equation. This is an equation just like 9.5, which we just did, which you have a quiz on today. And remember, in 9.5, we said there are infinitely many solutions to trig equations. You just add multiples of 2 pi onto your answers. Any multiple of 2 pi, or subtract any multiple of 2 pi. Now, there's not going to be infinitely many answers to these trig equations because they're triangles. If we get that beta is negative 30 degrees, that makes no sense, right? An angle in a triangle can't be negative 30 degrees. If we get that beta is 500 degrees, that is impossible. That's not a sensible answer. It could be an answer to this equation, but it doesn't make sense for a triangle. And that's the problem that we're going to run across in this section. There are infinitely many solutions to a trigonometric equation. We need to find all of the answers that make sense for a triangle. And so essentially, the only thing that we're going to use to figure out what makes sense for a triangle is what we've already used. If you add all the angles up, you should get 180 degrees. Okay? So let's unpack this a little bit. We need to solve for beta. So again, just like in 9.5, to solve a trigonometric equation, we want to get the trig function by itself. So we want to get sine of beta by itself. So multiply both sides by 8. That'll give us a sine of beta is equal to 8 times the sine of 35 degrees over 6. Now, it's a good idea when solving this. It's not mandatory, but it's a good idea to say, well, what is that right-hand side approximately equal to? Just so we can get an idea of what we're working with. Right-hand side is 8 times the sine of 35 degrees over 6. All right, that's about 0.7648. So this is going to have an answer, right? We're going to have to approximate it, but we know that sine goes between -1 and 1, and this is in the range of sine. All right, so now we take the inverse sine to get both sides. Beta is going to be the inverse sine of 0.7648. You type that in, arc sine of 0.7648. And you're going to get that beta is approximately 49.8892 degrees. And that's one possible answer to this trigonometric equation. But just like 9.5, remember there's infinitely many. This is only our answer in the first quadrant. Right? Infinitely many answers. This is our answer in the first quadrant, about 50 degrees. But there's also one in the second quadrant that also has a reference angle of 49.8892 degrees. So we need to find what is our angle in the second quadrant and does it make sense for this triangle? Okay. So in the second quadrant, the angle is going to be 180 degrees minus 49.8892, right? Because we go 180 degrees over and then back the reference angle. So that's going to be equal to 180 minus 49.8892, which is 130.1108. So we need to ask ourselves, does this make sense? We have one value for beta up here that definitely makes sense. Does the second value of beta make sense? Okay. Well, the only way that it would not make sense is if we went over 180 degrees. Okay. So to check, does this make sense? We need to say, okay, is 130.1108 degrees plus alpha, which is 35 degrees, is this over 180? And the answer is, it's not over, or sorry, we should phrase it, is this less than 180? And the answer is yes. So we're going to have two answers here. This right here, this line of logic from the last 5 minutes is the most important thing from this whole section. Or maybe not the most important, but the trickiest. Okay? To find our beta, we use the law of sines, and that set up a trig equation. But trig equations have infinitely many answers. We found one answer with inverse sine. But sine's positive in the first and second quadrant. So we had to look at, well, does the answer in the second quadrant make sense in the context of our triangle? So we found the answer in the second quadrant to be 130 degrees. We made sure that this 130 degrees is not too big. Right? We need to make sure that all the angles in the triangle are less than 180. And we don't know the third angle yet. So we just checked to see whether these two angles are less than 180 degrees. And because it was here, we're going to have two answers. If we got that beta was like, I don't know, 160 degrees, then it would be too big because then we get 190 over here, which would be way too big and it wouldn't make sense for a triangle. Okay? So we're going to have two answers. So what we usually do for this is we're going to call this first answer beta. And this second beta, we're going to call beta prime. All right, so we're going to have two answers. One is going to be our normal triangle with beta being 49.9. And we're going to have a second triangle where beta is much bigger. These triangles look exactly the same. Where beta is much bigger and it's going to be that 130.1 degrees. All right, and again, A is still 6. Alpha is still 35 degrees. This is beta prime. This is gamma prime. So we got to solve two triangles. This first triangle, we have two sides already. We have two angles. As soon as we get two angles, we can find the third angle. right? The third angle is just whatever it takes to add up to 180 degrees. So let's find gamma over here. Gamma is going to be 180 minus our two angles, 35 degrees and 49.9 degrees. You're going to get that gamma is about 95.1 degrees. So fill that in for the triangle. Gamma is 95.1 degrees. And we can also find what that third angle is, gamma prime. Right? Similarly, gamma prime is going to be 180 degrees minus these two angles. Minus 35 degrees minus 130.1 degrees. You're going to get that gamma prime is about 14.9 degrees. Fill that in. Okay. Oh, we still know B. So all we're missing is C and C prime, and we'll finish the problem. Yeah, so someone in my other class was also made that comment about 95.1. Thought that was funny. I had never heard of I don't listen to the radio, so I don't know anything about radio stations. So it's noteworthy to me that when people notice it, because I don't even remember the last time I've listened to a radio. So that's kind of funny. So we're almost done. Remember, it's a long problem, and we have only a couple minutes before you should be taking your quiz. So we're going to finish it kind of fast. We're going to finish by just using the law of sines one more time to find C and C prime. Okay? So, to find C, we set up law of sines just like we did at the beginning. We know alpha and A. So we're going to have sine of alpha, sine of 35 degrees over A, which is 6, equals the sine of gamma over C. All right. Oh, I don't have more decimals for gamma. I should have used more decimals for gamma, but we'll just use 95.1. So we need to solve this. Okay. So real quickly, you know how to solve this. I'm not going to go through it all. You can get that C is equal to 6 divided by sine of 35 degrees times the sine of 95.1 degrees. And you're going to get that C is approximately equal to, if we use our calculators, about 10.4. So C is 10.4, fill that in, 10.4. And we have to do the same thing for C prime. And again, we're running low on time, so I'm going to skip a few steps. But C prime will also be 6 divided by the sine of 35 degrees. But this time, it's going to be multiplied by the sine of gamma prime, which is 14.9 degrees. Right? This is gamma prime instead of just gamma. All right. And for C prime, what you're going to get is 2.7 approximately. So fill that in, 2.7. And we have our two answers. Now, before we are done, do our gut check. Biggest angle should be opposite biggest side. So the biggest angle on our first triangle is 95.1. The opposite side is 10.4. Good, that's the biggest side. Smallest angle is 35 degrees. Opposite side is 6. That's also the smallest side. Smallest angle should be smallest side. Biggest angle should be biggest side. So this is a good little gut check to do. Over here, biggest angle is 130.1 degrees. Opposite is 8, which is the biggest. Smallest is 14.9. That's opposite 2.7, which is the smallest. Good. So our answers are these triangles. We have two answers that solved this situation, this side-to-side angle triangle. And this is the hardest case. We'll do some more of the simpler cases, the one solution and the no solution, as well talk about areas on Friday. Okay, but go ahead and start your quiz now. All right. If you have any questions on the quiz, send me a message on Discord. All right. Good luck.